Hi, my name is Paul Holland. I'm an RST instructor, and I'm going to be talking to you today about test coverage. So, when we talk about test coverage and rapid software testing, we're not necessarily talking about requirements coverage. We're not necessarily talking about coverage of features. We're talking about coverage of the entire system that we're trying to test. So it's a little bit more in depth. Written requirements are not anywhere near the entire amount of coverage. So doing requirements traceability and calling that your test coverage is quite dangerous because a huge amount of the requirements of the system aren't ever written down. They're just expected to work, and you would be unable to come up with a list of all of the requirements if you tried to, because there's just so much that you take for granted. As an example, if I went into a bar and I ordered a beer, what do I expect to happen? And if I wrote all of the requirements, I said I would expect a beer to be brought to me that I've ordered, the right brand, and brought to me in a clean glass. Maybe that's everything I can think of. And so then the bartender brings me a beer an hour later. Oh, okay, there's a good requirement. I expect it to be brought in 5 minutes. So he brings it in 5 minutes, and the glass is this big. It's a shot glass. No, I expect it to be in a beer glass, a 500 milliliter glass. Okay, it comes and the glass is cracked, or it's chipped at the top and I'm going to cut my lip on it. Or he has his thumb in it, or when he puts it down, he slams it down and it causes the beer to overflow, or he spits in it. There's so many things that we just don't put down as a written requirement. You wouldn't dream of putting a written requirement to a bartender and saying, when you serve the beer, please don't spit in it. It's not something you would consider, but it's something that if it happened, it would be deemed unacceptable. So it is a requirement. So when we look at a system, we have all of these written requirements, usually sometimes in the form of stories, sometimes in the form of documents. However you are determining what is being coded, whatever is written down is incomplete. It's grossly incomplete. So when we look at talking about coverage, we try to fill in the gaps a little bit. We try to think a little more broadly about what we're going to be testing. So we create something that we call a product coverage outline. And the product coverage outline can be used to have discussions with the business, with the developers, to get a better feeling of what we mean by the written requirements. Not unlike having a given when then statement, which is designed to encourage discussion, a product coverage outline will encourage discussion as well. So a product coverage outline is an effective way to visualize your test coverage and the product itself. So what is a product coverage outline? It's a list of everything that you may have an interest in testing. It doesn't mean you're going to test everything in it, but it's trying to identify as much as possible the things that you plan on testing or that could be tested. So it's an inventory of the things you're going to be looking at. So this is an example of a product coverage outline. Don't worry if you can't read the details. The idea is just to sort of show you the structure. It's in a mind map format. This is an example. You have this could be for just a feature, or it might be a fairly simple entire product. But how would I create something like that? Well, to start, you need to start with something. It's very difficult to just sit down and create an end product just by going through it. And if you've never created this before, if you're new to mind maps, likely the first product coverage outline you attempt to create, or the first few, are going to be not great, but they will still be a good starting point and still be a good conversation starter. if I have found in my experience, if I show somebody a mind map that is incorrect, they very quickly get out a pen and they start writing on it. Or if it's on the computer, they'll um, suggest improvements. If I give someone a document to read and ask them for feedback, they'll say, okay, and then they usually don't read it. But there's something about showing a mind map that if there's something incorrect on the mind map, it bothers people and they want to fix it right away. So how would I start making a mind map? What do I write down first? Well, touring the product is, I find, the way that I tend to do it. If it's a brand new product that I'm new to, it's not necessarily a brand new product in general, and it's available. It's not a vaporware. It actually exists. I'll go and I'll do a tour of the product. I'll see all the elements. I'll look at the menu items, look at the sub-menus, the context menus by right-clicking, and I'll list off everything that I see. That's a good way to start. If it's not available yet, there's no product yet, it's all just in people's heads, I'll talk to the people whose heads it's in. I'll talk to the developers, talk to the business people, talk to the marketing team. If it's a subsequent version that's being worked on, that's likely not going to be too different than a previous version, I can look at the previous version to get an idea. Again, having a product coverage outline is fine. If it's wrong, it's a conversation starter, it's a guide. I can look at competing products. Oh, we're going to do something like Lyft is, oh, we're doing something similar to Uber. Okay, I can create something based on that as an example. And lastly, and I do mean lastly, I could read the functional specs. The reason I put that at the end, I like using my imagination, my creativity, thinking of things that aren't going to be written down, putting those in my product coverage outline. I have found once I read the functional specs, I'm now in that mindset, that groove, and the person who wrote the functional specs now has me in their hug, and I can't think about anything else because I've now read what they envision the product is going to be, and my creativity has been diminished. So I like to write out all of the things that I think should be in the product first. Some of them are going to be wrong. Some of them are going to be contradicting what's in the functional spec, but the functional spec or the stories or the JIRA tickets, however you have your requirements, they're going to be available for you today, but they'll also be there next week. And I can spend a week coming up with what I think should be in there, and then I can look at those documents. So we also want to do a heuristic-based approach. Part of the heuristic test strategy model from rapid software testing includes the mnemonic for test coverage of structure, function, data, interface, platform, operation, and time, or San Francisco Depot. I'm going to go through each one of those, and we want to put these elements into the product coverage outline where they make sense. So what do we mean by structure? Well, there we're talking about the software, the hardware, the components, and the individual procedures, the file structure, the server structure. So as an example, I'm currently working on an insurance system, and there is a policy server, there is a billing server, there is a claim server, and there is a contact manager server. There are also a few other servers, but those are the four main ones. That structure, how those systems talk to each other through message queues, I would put that in my product coverage outline. I would probably also break my product coverage outline into separate systems, because trying to do a single product coverage outline for that entire insurance system would become huge and likely unusable. So we're looking at the software. How is the code structured? Is it a bunch of microservices? Is it a big monolith? How is that broken out? And then are there any data files that are there? So non-executable files in addition to the code. And is there anything else beyond that we need? Print servers, things like that, third-party companies that we send to, balance load balancers, things like that. Function, this is what the product does. So if we're looking at, let's say, just the policy server and we're doing a mind map of that, what does it do? Well, at a very high level, it creates auto policies and home policies, personal and commercial. Okay, well, now we're up to 4 different types of policies, but then there's so much in there. There's the coverage that we have, the type of dwelling or the type of vehicle, the drivers, all of that information goes into the function of creating a policy, so those would be listed off. You're also going to find out as we go through this that there's going to be a lot of overlap. On the function side, I mentioned that there's going to be drivers, there's going to be dwellings, there's going to be vehicles, but those are also going to be in the data side. And in the data side, we've already listed them from the function side, so we don't have to list them again. You don't have to break it out by this is the structure side, this is the function side, this is the data side. You can put it in a easier to read format, maybe by function area, things like that. But you want to consider all of the areas that we're looking at. And in function, we're not just looking at what it does, but how it handles errors, how it can fail, the timings of, not the timings, the testability of it. Timing comes later. On the data side, anything that comes in, anything that goes out. So in an insurance policy, we're going to have your declaration page, we're going to have the policy, we're going to have letters that get sent out if you haven't made your payment, delinquency letters, cancellation of the policy, whether we cancel the policy or you call us and cancel the policy. We're going to have documentation there. How do we capture data? How does it come in? Where does it come from? All of those elements are part of data. Where is it stored? How is it stored? Things like that. Essentially any files that get referenced. So one of the things that we use is credit scores. So we make a call to a credit score company. They send us the credit score. We have permission from the customer to store their credit information for almost a year. And so we would be storing that in a secure way. And so that's something else we want to be looking at is the security of the storage. Is it hackable? Things like that of people's credit score and so on. Interface, how do you interact with it? In the product I'm talking about, the biggest interface is the user interface, graphical user interface. It's browser-based. So the interface would be a Chrome or Edge or Firefox or Safari, but you can also get a quote by going through an API. So that's something. There might be a physical interface to the server where it has network connections. If that's something that we have any access to, that's something else we could consider. So again, any way of interacting with the product, both physically and personally. Platform, this is the elements. I already mentioned this a bit in structure, but it becomes a little more clear here, where on the platform, we're talking about anything that our software relies on. So operating systems, browsers, the servers itself, and unlike structure, where we're talking about how they interconnect and how they talk to each other, in this case, we're looking at what we depend upon. So if we need a printer, then we depend on the print spooler and the printer itself to be there. So in the structure side, we would talk about the connectivity of it, but in the platform side, it would be more the elements that we need to work as opposed to those that we use from a functional point of view. It's a slight different way to thinking about it, but the reason we mention it in both places is we want to make sure that we're missing as little as we can. Operations is the second last piece. This is how it's used. So unlike function, which is an individual thing like creating a declaration page, that would be a function. How it's used would be a little more end-to-end. So an underwriter could log on with a customer on the phone and enter all of the data and end up with a quote, get the payment from the customer, and send the customer their policy. That would be part of operations. So how is the product used? So this is where we look at personas. Who would use it? How do they use it differently? How is an underwriter different from a broker? Things like that. And then finally, time. Time is one of the more challenging ones to look at because it's broad and not often thought about. So it can be, what if I click a button 5 times quickly? Or what batch services run overnight? When do they run? Are the queues polling? And if they are, how often do they poll? Or are they being pushed out? So it's an interrupt driven. And if they are being polled, how frequently are they being polled? What happens when the polling stops? How do we handle time zones? How do we handle daylight savings time? What about race conditions? What if 2 people are trying to edit the same policy at the same time? All of those things are time related, and you want to put pieces of those into the product coverage outline. And then so we started with a tour, and then we took that basic tour that we did, and then we went through the San Francisco Depot, and we thought about each piece of the system that we're going to be testing, and we added all of the elements that we talked about mentioned in San Francisco Depot, and we added that to the mind map. You will probably find that, as an example, the system I was talking about, the policy system, its mind map would become huge if we were doing a full product coverage outline on the entire system. You would probably want to focus on an individual component of that system, like a home policy, and then do a product coverage outline for just home policy, because trying to do the entire system, the mind map might become too big and too cumbersome. So start with a feature or an element and do that in as much detail as you can. And then you can use your product coverage outline you've created, show it to your team, get their feedback, ask them to make suggestions to correct it. And then you can talk about how you might be able to test the elements on it. And you can talk about that with the testers and with the rest of the team. And you should have a much better idea as to what you're going to test, what you have tested, what you're never going to test. And then you can report on it by using color coding and other types of methods. I hope you found this helpful. Thank you.